Hello, my name is Lewis Mota, and for this presentation, I'm going to introduce my final project that is based on the Olympic Games, specifically a dataset that contains all the information regarding to the Olympic Games from the last 120 years. So let's start introducing the Olympic Games on why I decided to choose this particular dataset. The modern Olympic Games or Olympics are a leading international sporting event featuring summer and winter sports competitions in which thousands of athletes from around the world participate in a variety of competitions. The reason why I decided to choose this particular data set was because it is well known that people spend a lot of money bidding of on which country is going to win a certain competition. And I was pondering about what are the probability or the odds of winning a certain country or a certain player based on the characteristic that that certain player have. And with that curiosity in mind, I decided to perform my analysis. For the data collection methodology, or basically the description of the dataset, this dataset contains 271,116 cases. These observations correspond to players that have participated in the Olympic Games since the 1896. Few of the attributes that are present in the datasets are, for instance, the name, the gender of a player, the age, the height, the weight, the country to what that player belongs, and the year and the medal that that particular player won in that competition, if any. In this case, for my study, I'm focusing on height and weight, including the gender, that is the variable that I'm going to use along with height and weight in order to predict the medal that a certain player may win depending of the characteristic that I previously mentioned. And this is the description of the variables that I decided to choose for my model. In this case, one of those if the distribution of heights that is normally distributed between men and a woman. In this case, the average height for a woman is about 165 centimeters, while for men the average weight was about 179 centimeters. One characteristic of those two variables is that, for instance, for females, there is a higher variability compared to men, and both the variables have a lot of outliers as shown in the graph. The second variable that I decided to use for the study was the weight, that is, I can say, is negatively skewed and also have a strong presence of outliers. For instance, based on the graph, we can conclude that the weight or the mean weight of a female is around 75 kilograms, while for men is about 86 or 87. Now for the inferring part, my main goal was to study, from this study was to analyze what are the odds of winning a certain medal based on the variables that I previously mentioned. In this case, I chose to run an ordinary logistic regression because I was assuming that the variable have a specific order that were from getting a gold, a silver, or a bronze medal in that order. In this case, this ordinal logistic regression model had four assumptions. The first one was that the variable that we are going to measure was in an ordinal level. In this case, the metal variable that is considered gold, silver, bronze, or none, depending of the approach that I decided. And the second assumption was that the one or more variables or independent variables are continuous or ordinal. In this case, the weight and height are both continuous variables, so I could say that I made that assumption. The third assumption was that there is not multicollinearity. In this case, I confirmed that using the variance inflator factor in order to test the correlation between variables like the height and weight, and I find out that those variables are moderately correlated, so I could carry on the study. And finally, the fourth assumption is that the odds are proportional. In this case, the only way to test that assumption is when we fit the model to the data. In this case, this is a model that I created for predicting what is the medal that a certain participant is going to win based on the height, the weight, and the gender. In this case, we have the coefficient for the two variables, height and weight, which suggests that when there is a decrease in one unit in the height and the weight of a certain player, the odds of getting a specific kind of medal decreases. In this case, the probabilities or odds are going to decrease from, for instance, from bronze, from gold to silver, and from silver to bronze, depending of the height and weight. Also, there is another variable that is the gender, as I mentioned, that suggests that depending of the gender, those odds are going to increase for about 0.04%. In this case, these coefficients are related to the odds of getting a specific medal. In this case, those values are fixed and will only change depending on what are the values that we gave as an input for the height and weight variable, including to gender. Once I fit the model, I could confirm the fourth assumption for this type of regression, that is that the rule of the proportional odds. In this case, I perform a kind of test that is called the Brand test, that tests if the proportional of assumption is fulfilled. In this case, when I perform that test, I got the output that the parallel regression assumption holds. That means that the data and the model that I created meet that assumption. Based on that, I could conclude that the model was a good fit for the data. Finally, I decided to input a few variables in order to test the probabilities of winning a specific medal. in this case, when you can see a short display for that variable in this column, and you can see that for a height of 179 centimeters and a weight of 76 kilograms for a male, the probability of winning a gold medal is about a 33%. For for the silver medal, the probability are almost the same at 33%, and for a bronze medal, the probabilities are at 34%. And in the same way, I compute all the probabilities for the test set that I decided to give as an input in order to test the model. Finally, as a conclusion, I learned that the probability of getting a specific medal are somewhat related in the sense that they are about the same. However, I found out something interesting that is the reason why I decided not to trust the model, and is that the model does not predict with a high accuracy what medals a certain player won once I trained the data. And based on that, I decided that maybe for a future I would need any other kind of variables in order to test what are the odds of winning a certain event, because with the information that we have in the data set, I don't think that it is possible to predict like with accuracy what are the real odds of winning a specific medal. In addition to that, I realized that that model, even though it can fit the data, it actually is not the best model that I could fit in that particular data. With that, I conclude my presentation. I hope you could understand my project. And if you have any question, I will try to be available on the chat so I can answer you in a better way. Thank you for your attention.